Planetary transits are some of the rarest and most fascinating celestial events observable from Earth. A planetary transit occurs when a planet, such as Venus or Mercury, moves directly between the Earth and the Sun, appearing as a tiny black dot crossing the Sun's surface. This phenomenon is not only a breathtaking spectacle for skywatchers, but also an event of immense scientific importance. Transits are unique to the inner planets, Mercury and Venus, since they are the only planets in our solar system whose orbits lie closer to the Sun than Earth's. From Earth's perspective, these transits happen only when the orbital planes of these planets align perfectly with Earth's orbital plane, or the ecliptic. In this article, we'll explore the mechanics of planetary transits, their history, significance in astronomy, and how they've shaped our understanding of the solar system. What is a planetary transit? A planetary transit is a celestial event where a planet passes directly between the Earth and the Sun, appearing as a small, dark silhouette moving across the Sun's bright disk. While similar to a solar eclipse caused by the Moon, planetary transits differ significantly in scale and frequency. The smaller size and greater distance of planets like Venus and Mercury make their transits appear much less dramatic than a lunar eclipse. These transits can only occur when the following conditions are met. The planet is in inferior conjunction, meaning it lies directly between the Earth and the Sun. The planet's orbital plane intersects Earth's orbital plane, aligning all three bodies in a straight line. Because of the slight tilt of the inner planet's orbits relative to Earth's, this alignment is relatively rare, making transits special occasions for astronomers and sky enthusiasts. The frequency of planetary transits. Planetary transits are rare due to the precise orbital alignment required. The frequency of transits for Venus and Mercury varies significantly. Mercury transits. Mercury's smaller orbit and faster orbital speed make its transits more frequent, occurring about 13 to 14 times per century. They happen in May or November when Mercury's orbit crosses the ecliptic plane. Venus transits. Venus transits are far rarer, occurring in pairs roughly 8 years apart, separated by over a century. The most recent transits occurred in 2004 and 2012, and the next pair will not occur until 2117 and 2125. Why planetary transits are important. While planetary transits are visually subtle, they are scientifically significant. Historically, they played a crucial role in advancing our understanding of the solar system, particularly in calculating distances and validating astronomical theories. Measuring the astronomical unit. One of the most important historical uses of planetary transits was to calculate the astronomical unit, AU, the average distance between Earth and the Sun. In the 18th and 19th centuries, astronomers observed transits of Venus from multiple locations on Earth, using the principles of parallax to determine the AU with remarkable accuracy. By measuring the slight differences in Venus's position against the Sun from different vantage points, they could calculate the distance between Earth and Venus, and subsequently the Earth-Sun distance. This groundbreaking achievement allowed scientists to establish a scale for the solar system, paving the way for modern astrophysics and space exploration. Understanding planetary orbits. Transits also provided insights into the orbital mechanics of planets. By carefully timing the start and end of a transit, astronomers could refine calculations of a planet's orbital period, inclination, and eccentricity. This data helped validate the heliocentric model of the solar system and contributed to the development of Kepler's laws of planetary motion. Modern applications. Exoplanet detection. In modern astronomy, the principles of planetary transits are applied beyond our solar system to detect exoplanets, planets orbiting stars outside our solar system. When an exoplanet crosses in front of its host star, it causes a slight dimming of the star's light, detectable by telescopes like NASA's Kepler and TS emissions. This method, known as the transit method, has led to the discovery of thousands of exoplanets, including Earth-like planets in habitable zones. The history of planetary transits. Early observations. The first recorded observation of a planetary transit was made by Johannes Kepler, who predicted a transit of Mercury in 1631 based on his calculations of planetary orbits. However, it was Pierre Gassendi who successfully observed the event, marking the first time a planetary transit had been scientifically documented. Kepler also predicted a Venus transit in the same year, but it was not visible from Europe. Observations of Venus transits began with Jeremiah Horrocks and William Crabtree, who independently witnessed the 1639 transit, refining Kepler's calculations in the process. the golden age of transit observations. The 18th century saw a surge in interest in planetary transits, particularly those of Venus. The 1761 and 1769 transits became global scientific events, with astronomers traveling to remote locations worldwide to make observations. These efforts aimed to measure the astronomical unit with unprecedented precision. One notable expedition was led by Captain James Cook, who observed the 1769 Venus transit from Tahiti. The data collected during these transits revolutionized astronomy and expanded our understanding of the solar system. Notable planetary transits: the 2004 and 2012 Venus transits. The 21st century witnessed two transits of Venus, in 2004 and 2012, drawing global attention. These events were widely observed by amateur and professional astronomers alike, using modern technology to collect data and capture stunning images. For many, these transits were a once-in-a-lifetime experience, as the next Venus transit will not occur until the 22nd century. Mercury transits of the 21st century. Mercury transits, while more frequent, remain eagerly anticipated events. Recent transits occurred in 2006, 2016, and 2019, with the next expected in 2032. These events offer opportunities for scientists to refine measurements of Mercury's orbit and atmosphere. Cultural and symbolic significance. Planetary transits have not only scientific value but also cultural and symbolic importance. Historically, these events were seen as omens or divine messages. In ancient cultures, celestial phenomena often influenced myths, rituals, and decision-making. Today, transits inspire awe and curiosity, serving as reminders of humanity's connection to the cosmos. They also provide opportunities for public engagement in science, with observatories and educational institutions organizing events to share the wonders of astronomy with wider audiences. Conclusion: planetary transits are rare, breathtaking events that highlight the intricate dance of celestial bodies in our solar system. From their historical significance in measuring the scale of the universe to their modern applications in discovering exoplanets, transits continue to advance our understanding of the cosmos. Whether you're a seasoned astronomer or a curious skywatcher, witnessing a planetary transit is a humbling reminder of our place in the universe. These events connect us to centuries of scientific exploration and the timeless beauty of the night sky. If you've ever observed a planetary transit, share your experience in the comments. And don't forget to stay tuned for the next opportunity to witness this celestial spectacle firsthand.